Good day, grade 7s. My name is Mrs. Christel Ace, and today I'm going to explain two very cool concepts to you: pneumatic and hydraulic systems. Both these systems are used for mechanical advantage. So here we go. Using pneumatics and hydraulics to obtain a mechanical advantage. Have you ever inflated a bicycle tire with a pump? Or have you ever wondered how the brakes of a taxi work? These systems use air or liquid such as oil to transmit forces and make things move. What happens when you blow up a balloon and let it float away? The balloon is propelled through the air. As the air inside it rushes out, and pneumatic and hydraulic systems use the same principle. These systems are utilized in complex machines that assist humans to perform activities that we would not be able to do by ourselves. Okay. What are pneumatic systems? Whoa, big word. Yes, it's a fancy word, and it actually means using air or gas. Okay, so it's just remember pneumatics, air or gas. Okay. What are pneumatic systems? To move objects, a pneumatic system employs a force of compressed air or gas. A pump or compressor compresses the air into a container. When compressed air is released, it generates force. This force can provide mechanical advantage if it causes a mechanism that it needs to move. Everyday pneumatic systems include a bicycle pump and a dentist drill. Other examples can be seen at automatic railway and bus doors. Because air is introduced into and then removed from pneumatic systems, they are open systems. We can even hear the hissing sound made by the air as it escapes the system. What are hydraulic systems? Oh, again, a big word. Don't worry. Hydraulics just means using liquids such as water or oil. A hydraulic system operates like a pneumatic system, except that instead of compressed air, it uses liquids such as oil to move items. To offer mechanical advantage, hydraulic systems use fluid in cylinders to convert small forces into big forces. Vehicle braking systems and industrial machinery such as hydraulic lifts and front-end loaders are notable examples of machines that use hydraulic systems. Hydraulic systems are closed systems because the liquid moves from one container to another without allowing any of the liquid to escape. As a result, in a hydraulic system, an input force on the liquid in the reservoir produces rapid output response. Also, very little input force is required to achieve considerable mechanical advantage. Hence, hydraulic systems are quite powerful. Now, for your practical investigation. Investigate differences between pneumatic and hydraulic systems. You will discover the difference between pneumatic and hydraulic systems in the activities that follow. For these tasks, work in groups, but keep track of your own observations in your workbook. You will need 3 plastic syringes without needles, 2 equal volume and 1 smaller one. Short length of plastic tubing which fits snugly over the ends of each syringe, a bowl of water, a small box filled with a few stones. You can use even a matchbox, a ruler, and a large sheet of paper for the measuring sheet. So, the measuring sheet you can create by taking an A4 piece of paper and drawing a line in the center from top to bottom. Keep track of your observations as you finish each task. task 1. For task 1, you are going to need 2 equal size syringes and plastic tubing. Okay. Pull out the plungers from the 2 syringes of equal size syringes until they are both halfway up the syringe chambers. Connect the syringes using the plastic tubing. This is pneumatic system because the syringes are filled with air. Now, for step 1, place your thumbs on both plungers and press down on one of them. So, press down on one of them. What's happening? You see, this one came out. Pressing this side, this one comes up. What are your observations? Make a note of your observations in your workbook. Place the box to the right of the line of your measuring sheet. Align the matchbox edge with this line. Push one of the syringes plungers all the way in and set it against the right-hand end of the matchbox. The plunger on the other syringe will be out. Push the plunger that is out. This is the input syringe. Take note of what occurs when you are doing this. When you press the plunger down, force is transferred from the input syringe to the output syringe. It should move the box over the line to the left. Make a mark on the paper where the matchbox landed. How far did your box move? Okay. For task 2, you're going to use the same syringes and plastic tubing, and we're going to use water for our hydraulic system. Pull out the plungers from the 2 equal syringes. Place them in a bowl of water so that the syringe chambers fill up with water. Working underwater, push the plungers into the syringes until they are halfway up the syringe chambers. Put the tubing under the water and connect the 2 other ends with both syringes, making sure that there is no air in the system. Remove the system from the water and dry it off. Step 1. Again, with your thumbs, push on one side of the side of one of the syringes. The other syringe will go out, and then repeat the process. What are your observations? Write it in your workbook. Again, repeat the steps of task 1. Okay. Place the box edge next to on the right side of the measuring line. Then plunge the one syringe down and then place it next to the box. And then when you plunge the other syringe, the output syringe will move the box over the line. Now, what are your observations? And measure how far did your box move. Okay. Now for task 3, you are going to use 2 unequal syringes filled with air. This is with air, so it's a pneumatic system. Push the plunger of the large syringe all the way in, then pull the plunger of the smaller syringe all the way out, almost to the top of the syringe. Like this. Big syringes in, small syringe out. Connect it with the plastic tubing. Okay. Now with your thumbs, press down and observe what is happening. Okay. Write your observations in your workbook. Okay. Use 2 syringes of unequal size, one large and one smaller. Push the plunger of the large syringe all the way in, then pull the plunger of the small syringe all the way out, almost to the top of the syringe chamber. Plastic tubing should be used to connect the two. Okay, so now step one was, what was your observations? And you had to write it down. Then step two, you're going to repeat the same process like in task 1 and 2. Now you're going to press down the big syringe until all the way down, and the smaller syringe will be out. Align your box again with the measuring line, and you place the big syringe, which plunger is in, on next to the box, and then when you squeeze the smaller syringe, the plunger will move the box over the line. Measure how far your box moved. Repeat this process by switching the two syringes. Then you will indicate what happened when you use the small syringe as an input, and you will observe what happened when you use the big syringe as the input. Now for task 4, evaluate the transfer of force between two unequal syringes filled with water. Remember, water means hydraulic system. Fill the large and small syringes with water after connecting them. Remember to do this underwater to avoid air bubbles in the system. Before filling the systems with water, make sure that the plunger of the large syringe is completely compressed. Then dry your system off. Okay. And let's do. So for step 1, again, you're going to use your thumbs and press on the big syringe. And then you could tell it's completely down. You're going to press on your small syringe until it's completely down, and you write your observations in your workbook. Okay. Step 2, you're going to align your box again with the edge on the center, the middle line of your measuring tape, measuring sheet. You're going to push down the plunger of your large syringe, so the small syringe will be completely out. You put it next to your box, and then when you squeeze the smaller syringe, the other output syringe will then move the box over the line. Measure how far your box moves. You can repeat this process by switching now your small syringe and your big syringe as input and output. What happened when your big syringe was the input, and what happened when your smaller syringe was your input? Okay. Now, in the table on your worksheet, you are going to write down your observations or force transfer between two syringes of equal volume and force transfer between two syringes of unequal volume, both with air and with water. Okay. Okay, what did you observe in the two systems that used equal size syringes? In the systems that used equal size syringes, when the system was filled with liquid, it moves the matchbox further than it was filled with air. This is because air can be compressed and the action is delayed. So there is greater force transfer when using hydraulic systems, the water. Okay. What did you observe in the two systems that use different size syringes? In the system that used syringes in different sizes, although it was more difficult to push down on the large syringe, the distance the smaller syringes moved was greater. More force is needed to produce movement. The force transfer was greater when the large syringe was the input syringe and the smaller syringe was the output syringe. Okay. Okay, let's stop share. Can you remember what is a pneumatic system and what is a hydraulic system? Pneumatic systems use air or gas. Hydraulic systems use liquids such as water and oil. Now, for your homework, you are going to build a mechanical lifting system using either pneumatic or hydraulic systems. So you are allowed to use everyday household items. In my case, I used toilet rolls and cardboard and syringes and tubing to create my my pneumatic system. I didn't use water, I used air. Okay. Build a small-scale lifting device out of syringes and common household items, utilizing either a pneumatic or hydraulic system. Consider the observations you made while investigating pneumatic and hydraulic systems. Okay, so this is how mine works. I'll show you. Hi. I hope you enjoyed this as much as I did. Can give you a lot of ideas and inspiration to go and build your own hydraulic or pneumatic lifting device at home. Okay, enjoy your day and great seeing you. Bye.